Okay, so here's some footage we created on our journey, where it was a lot of trial and error. And in my hand you can see a potentiometer which you can turn around only 270 degrees. And at first I wanted to take this one, but it wasn't possible because we needed something which has more turns. And then I found on Conrad one which you can turn multiple times, and it was also super small and tiny, which is also pretty good. And the original plan was to take the knob turns and read them out from the board, but it wasn't possible. So you can see there I fitted the potentiometer in. I glued it in with this blue UV light glue, which worked out pretty well. And I also attached the knob, this little knob, to the plastic inside, and just put some light on it. And actually you can see some shiny still overdue over there, and it worked out pretty well. I then connected the contacts to a multimeter so I can read out the values of the potentiometer. So right now it shows 18,000 ohms, which is the value if it's on the farthest on the left. So now if I turn the knob, you see the metal indicator, which normally indicates the radio frequencies, is also turning around, and also by turning the volume up the values are going down, so this is a good sign. And also when I turn it in the other direction, the values are going up again, and this is what we actually wanted. I also measured how much turns the left knob can make, and it are 5 turns. So the highest value we have is 18,000 ohms, and if we turn it down to the lowest point we get about 10,000 ohms. Here you can see the Raspberry Pi connected to the microcontroller, which is connected to the potentiometer. And now if I turn the knobs on the PC, you can see that it's not showing the ohms but digital values, because they are converted by the microcontroller and read out by the Raspberry Pi. So this is needed so we can use those values to implement them in the code. Here you see the audio amplifier board and how its volume knob is turned mechanically by the volume knob. And I make a little pause here because actually we thought this is a great idea, and it actually would have worked out pretty well. But the problem was that the sound amplifier amplified the sound from the lowest to the highest point by maybe 5%, so we couldn't actually use it as a real volume knob. And we decided to go for this route at first because we couldn't read out the actual values from the real volume knob that is inside the radio. Maybe it was because it was still wired into the other connections. I then tried at the end cutting all connections loose and measuring it, and then I finally got the right potentiometer points. So we could use those to connect them also to our microcontroller, which were read out by the Raspberry Pi. And then we had the digital values, which allowed us to control the volume by our Python code. Here we are soldering some short wires to the microcontroller so we can connect them to the board afterwards. We also needed to cut some holes into the plastic so we can put in our USB power adapter inside the case, and also we created a big hole where the batteries are so we can put there in the whole project. Here we are actually pretty close to being finished, but the problem we had was that our program would just randomly restart itself or wouldn't work properly, and we thought we maybe have somewhere a shortage, or maybe a wire is loose or wasn't soldered right. As you can see on the Raspberry Pi there are a lot of connections, and we actually had to use some pins 2 or 3 times, and we searched for quite a while. And actually, as it turned out, we used the second microcontroller for the second potentiometer, which wasn't actually necessary because we can use at the first microcontroller also another pin for connecting the second potentiometer, but there we didn't do that, and so it took us quite a while to figure out what was wrong, but after we found our mistake, we corrected it and everything worked fine again. And we closed it up and had the finished product. So now I have some outtakes ready for you. That was actually after this process where we thought now we have it and it worked fine, and then this happened. But watch for yourself.
Jetzt ist er tot.
Also ausgegangen?
Ja.
Ups. Ja, wir haben irgendwo einen fiesen Wackelkontakt drin. Die Frage ist nur, wo?
Weißt du, ich starte gerade mein Video und es macht einfach nur...
Oh Mann, hast du den vorher einen Moment noch? Was? Niemand wird uns glauben, dass es jemals funktioniert hat.